Okay, Assalamualaikum to Sir Abdullah bin Yahya. So today our group will present about line integral for our group project assignment. So the team members consist of myself, NURUL BINTI ARIFFIN, alongside with KHAIRUL bin AZIZ and NURUL SYAMILA binti MOHAMMAD IZAHAR. We three from CS2904A. So coming to introduction, so we know all about single variable integral of the structure fx dx to integrate from a to b, where the domain of integration is an interval ab. Such an interval can be considered a curve in the xy plane, since the interval characterizes a line portion with m points a0 and b0. All in all, a line section situated on the x pivot. Assume we need to coordinate over any curve in the plane, not a little more than a line fragment on the x pivot. Such an errand requires another sort of integral called a line integral. So a line integral is integral which the function can be integrated or to be integrated is determined along a curve in the coordinate system. So the capability which is to be coordinated might be either a scalar field or a vector field. So we can integrate a scalar value function or a vector value function along a curve. The value of the line integral can be accessed by adding every value of point on the vector field. So as you can see, line integral formula for scalar field and vector field are as shown in the slide. So moving to the questions, so we have two questions. The first question is evaluate the work done where fxyz is equal to xzi minus yzk, and c is the line segment from -1 to 0 to 301. And the next question, question 2, is here's parameterization of the straight line wire from 12 to 43. The speed of the parameterization is not constant but depends on t, which the equation qt equal to 3t squared minus 2 t squared plus 1, where t is between 1 and 2. Using the density fxy equals to x plus y, calculate the mass of the wire. So moving to the next member.
So I will explain the manual calculation for question 1. Next slide. Now I will explain how to solve the first question, which is evaluate the work done, where vector f in bracket of x, y, and z is equal to x z vector I minus y z vector k, and c is the line segment from -1 to 0 to 301. So as we can see, I already state that the formula of work done, where work done is equal to integration for a to b for vector f multiplied by the differentiations of rt dt. So when the equation asks to evaluate the work done, we need to always remember that this type of questions contain 4 steps, which are first step, we need to find the vector of rt. The second step, we need to find the differentiations vector of rt. Step 3, we need to transform the vector of f x y z to vector ft. And the last one, step 4, which is find the work done by using the formula of work done. So we move to the first step, which is find the vector rt. To find the vector of rt, we need to identify which method is suitable for the question. Since the question gives us a line segment from -1 to 0 to 301, so we can conclude that we will use the equation of vector rt as shown in slide. So after that, we need to identify which x node, y node, and z node, and which x1, y1, and z1. For this case, x node is equal to -1, y node is equal to 2, and z node is equal to 3. While x1 is equal to 3, while y1 is equal to 0, and z1 is equal to 1. So after that, we will substitute all the value in the first equation, and after all the value calculated, we will get the vector of I, j, and k, where vector I is equal to -1 plus 4t, vector j is equal to 2 negative 2t, and the vector of k is equal to t. So the step 2, we need to find the differentiations of rt. So this equation is actually, we need to differentiate the answer we get above, where we will get vector of 4, -2, and 1 after differentiations, the vector of rt. So we move to the step 3, transform the vector of f bracket x, y, z to vector of t. So from vector rt, we know that x is vector of I, which is -1 plus 4t, y is 2 minus 2t, and z is equal to t. So from this, we need to replace x, y, and z. So the result will be vector of 4t square minus t, 0, and 2t square minus 2t. The vector of j is 0, since the equation given is only in terms of vector I and k. So the next step is step 4. We need to find the work done by using the formula of work done. So after we already have the vector of rt and the differentiations vector of rt, so now we can find the work done for this equation by substitute all the value in the formula. So the answer for this question is 3. So now we will move to the maple instruction for question 1. So for the mapper instruction, the first coding is we need to type the restart, and after that we can click enter, and now we can start to solve the equation. So after we type with vector calculus, the result gives us the blue color, and after that we move to the width in bracket plots, and the result also in the blue color, as you can see. By doing all that, so now we can move to the substitute the vector of RT, differentiations of the R, a vector of F that was already in terms of T, and after that we do the dot product of F dot dr, and the last one we will integrate the dot product, and the answer given was 3. So we can see that the manual calculation and maple instruction give the same answer. Now the next slide will be explained by KHAIRUL.
Okay, now for manual mathematical calculation for question 2, we can divide it into 4 steps. The first step is we need to find the QT for the given curve, but the question already provides the QT. So move to step 2, which we need to find the magnitude of differentiation of QT. For the differentiation of QT, we get Q prime T is equal to 60 and 2T. Now we can find the magnitude, which magnitude of Q prime T is equal to square root of in the bracket of 60 squared plus in the bracket of 2T squared, and we get 2T set 10. Now for step 3, we need to find the FQT since it already in the form of T. So FQT is equals to 3T squared minus 2 plus T squared plus 1, and we get 4T squared minus 1. For the last step, we need to evaluate the integration of FQT times with magnitude of Q prime T from A to B. Substitute all the information that we already calculate, and the final answer is 5 set 10. For maple calculation for question 2, first, as always, we need to start with restart, then within the bracket vector calculus, and within the bracket plots semicolon. If we want to see the graph for QT, we can write it as plot open bracket 3t squared minus 2, comma t squared plus 1, close bracket, comma t equals to 1 until square root 2, close bracket, and semicolon. And we can see the 2D graph. Now we need to find the differentiation of QT. So we need to write the equation first as it's stated in the question, and we can write dq colon equals to diff in the bracket of q comma t semicolon, and we get its differentiation, which is 60 and 2t. To find its magnitude, we can write as vector calculus in the bracket of norm in the bracket of dq semicolon, and we get 2t set 10. To find ft, we need to write as ft colon equals to 3t squared minus 2 plus t squared plus 1 semicolon, and to find the answer, we need to write as n colon equals to ft semicolon, and we get 4t squared minus 1. Now, we need to find the dot product between ft and magnitude of differentiation of dq. So we can write it as n colon equals to dot product open bracket ft comma vector calculus open bracket close bracket open bracket dq close bracket semicolon, and we get the answer, which is 2 in the bracket of 4t squared minus 1 times set 10 times t squared t squared. And finally, we can find the scalar field, which is we can write it as integration of f ds colon equals to integration of 2 in the bracket of 4t squared minus 1 times set 10 times set t squared from 1 to square root 2, and we finally get 5 set 10, which is the same answer for the manual calculation. So I think that's all from us. Thank you.